Hello and welcome back. So we're playing a Stationeers playthrough and hopefully by now you've been watching the previous videos and you've seen that we have been building our base on Mars. So we started off with a very simple base based around this greenhouse that you see here. And then from there we have moved out and built a number of pieces of automation. So what I'm going to do, I'm actually going to leave the hab. I must remember to close and lock my helmet, and let's go outside. I ended the last video inside, having had a drink and some water. Whoops, nearly trod in some slush there. I've managed to destroy a large amount of biological material during the production of this base. So here we are. Last time we resited the machines out here, and we enclosed the ingot store, which was an unplanned piece of construction, but we needed to do it because we discovered that they were showing up damaged by the storm we had in episode 7, I think, or was it in episode 8? I can't actually remember when the storm happened. We've had a couple now, but we nearly lost the steel, and that was a bit traumatic. I do remember that. Okay, so our ingot store there is all organised and should be fairly automated and running nicely. We do need to go and do some more mining, but we're not going to do that in the middle of the night. So I think now we've got a working furnace so we can make alloys. We have got a working atmosphere processor. The solar array is tracking. Actually, this is also quite convenient, by the way, on this tracking. If you've got it set up, you can estimate how long it is until the end of night, because you'll see these are actually tracking back down towards the horizon and will be down there when the sun rises. So that's just a kind of useful little feature. I think I'm going to put a piece of floor grating across here because although that didn't collapse when we removed the frame, it just visually offends me bluntly. So I think we're going to do that. I'm pretty sure we'll need some more iron. Yes, we will. So let's use our press the magic button and wait and see what happens. I feel that there needs to be a bit more feedback here. We might have to build a little piece of code somewhere that detects whether something fell out of the hopper. Yeah, I don't think there's actually any left in there, is there? No, there is. It just didn't work. Okay. Let's press the button again then. Yeah, there we go. I think I have to hold the button until it pops out by itself for it to actually register. Yes, that's exactly what it is. I'm clicking it too quickly. Okay, so you can see these ingots are slightly damaged, but that's fine. We're going to mash them all up in here anyway. But perhaps we will build a little simple piece of automation to show whether or not that's registered. Anyway, not right now. We are not going to get sidetracked. We're going to finish the job we said we were going to do, and just put a piece of floor grating up there. I probably ought to print a whole load more, to be honest. There's plenty that needs doing, but there we go. Whoops, well, it doesn't look great, does it? But you know, at least it's closed in. We'll probably put floor grating along there at some point. Okay, so we're kind of in a reasonably good state, to be honest. I must remember to close that valve. Again, this probably needs some automation. There are a number of places that I think some safety features might be useful. In here, also in the atmosphere mixer here, and probably in the fuel mixer is even more important. So I think we're going to go ahead and actually do some safety implementation. It's not exactly safety first. We've been running like this for a little while. It's probably more like safety sort of last minute. But let's do something before we have an explosion. So I have actually got some IC code which we can use to control the mixers, which I wrote on a previous playthrough. That really didn't do anything, did it? Right, okay, this is definitely going on my list of things I want to do. This is already irritating. I guess the problem is there's also no way of knowing. There we go. actually if it's just empty. Definitely needs a bit more thought for a more sophisticated solution. However, let's get this built. So I've got some IC code written, so we're going to build a couple of ICs. Let's build one to start off with which can control the mixers, because actually I'm pretty sure we had this set up to control both mixers off one chip, because obviously that saves raw materials, so that seems like a good thing to do now. If we mix together hot hydrogen, hot oxygen, that's going to combust inside the fuel tanks and set the fuel off. Similarly, if we mix together hot gas to go into the hab, we're going to potentially overload our ability to cool it back down again and kill everything. So I think that's the first thing to do. So I'm just going to let that print. Let's turn that on. Right. Actually, I might just pop that in there. We'll label that. I think that's probably a good idea. We didn't label this one, did we? Yes, we did. Okay, let's filter control 1. This one's going to say IC housing and mixer control. And later on we'll start putting together systems that will actually monitor all of these ICs that are running and various other statuses around the base, and feed them into a supervisor system that can send us alerts if things go wrong as well. That's quite a way off, but it's pretty cool when you get that working. Right, so we want to set that to programming only. We're going to go to edit, and we're going to go to the library and mixer control, stop mixing hot air or fuel. That's exactly the one we need, so I'm going to overwrite that. Okay, so this looks like what we need. This is fairly recent code, which is good because obviously older code there is a risk that the definitions of the hardware have changed, or things like ignition thresholds. Obviously there's been various releases. The game itself is still in early access and the devs are super active updating it, so things do change quite a lot. It's good when you find some fairly recent code. So I'm just looking at this code while I'm talking, just to see what it is doing. So this one's actually set up to be able to deal with 3 mixers, a fuel mixer, an air mixer, and a CO2 nitrogen mixer. So this is pre-mixing carbon dioxide and nitrogen before it goes into the air mixer, which is quite a useful setup, but it's a piece of hardware we haven't built yet, so we will set that up as well. That's going to need another mixer, and it's going to need some more pipes, I suspect, although there's probably some in the locker. The reason for doing that is we want to get some CO2 into the greenhouse air, because that's what plants need to grow. Otherwise they will, at best case, get no bigger. I don't think they actually die without any, but I could be wrong, but they certainly don't grow without any, so we will need to do that. But you'll see this is then designed to look at the tanks of the oxygen, the hydrogen and the nitrogen, and check, first of all, the first thing it does, check the temperature on those, and then after that it will set or load the setting rather from the fuel mixer, so it knows whether it's turned on or off. The reason for that is what we don't want to do is to make it automatically turn on every time the temperature gets low enough. We don't want to automatically convert all of our oxygen and hydrogen into fuel, but we do want to be able to turn it off if it's left turned on and the temperature rises. We then do some checks on the temperature of those tanks, so we check the temperature here of the oxygen and the temperature here of the fuel, and then we do the same here with the temperature of the oxygen and the temperature of the nitrogen. We do the same here with the temperature of the oxygen and the temperature of the fuel. And what we're checking each time is for the air mixer whether it's over 303 Kelvin, which is 30 degrees C, and for the fuel mix, whether it's at 283 Kelvin or more, which is 10 degrees C. The combustion point of fuel is actually around 20, but you'll get some fluctuations in temperature as you alter the pressure. So what we don't want to do is to combine the two, pump them into a pressurized pipe, increasing the temperature and cause it to explode, or in fact just for it to be so close to the ignition threshold that the sun does the same thing. So what it will then do is it will check here whether or not, well, first of all, these will hold information to show whether they are both okay in each instance. So are both the fuel tanks at a sensible temperature, a safe temperature, that will go into this R7 register, and are both of the air tanks at a sensible temperature, they'll go into R8. What we will then do is we will say if the fuel pump is actually turned off, then we will jump over and we'll go straight to this ignore. But if it's turned on, then we will make the setting of the fuel pump equal to whether or not it's a safe temperature. So if the temperature is too high and it's not safe, that will send a 0 to it and turn it off, stop mixing. If it was already turned on, it will jump over it because it's not equal to if it's already turned off, rather, it will jump over it. If it's turned on, it will turn it off if that goes too high. If it's on and it doesn't go too high, it will stay on. Then we will move here to the other two mixers, and it will then turn those on or off. So if they are off and the temperature gets cool enough, it will start mixing, and if they're not, it will if they get too hot, it will stop the mixing. Now the only slight issue we've got here is there's no control here that's actually monitoring any pressure build-up between these two. So there is a risk that can happen where actually we get an excess pressure building up between the two mixers, and that can happen if, for example, we have an excess of carbon dioxide and nitrogen, but we don't have any oxygen, so that the oxygen mixer has nothing to add in, and that can blow up the pipe. But we've minimized the chance of that happening because we're going to mix the carbon dioxide and the nitrogen together and add that mix to the oxygen. And we know that on Mars carbon dioxide is plentiful. We also know that oxygen is relatively easy to get. The thing that's often runs out and we have none of in the store tank is nitrogen. So that will actually stop the first stage of that two-stage reaction rather than the second. So we shouldn't build up any excess pressure between the two mixers, but that's just a bit of an issue with this setup that's worth being aware of. Anyway, I've talked you through the code, possibly in more detail than you wanted to see. The only other point I should mention is, as we always do when you get to the end of the code, we do a yield, which means actually stop and wait until the end of the next tick, a tick being 1 unit of game time, and then jump to the loop, which is line 10 here. So go back and reread the settings on all of the input devices, and then go back through and redo that calculation, resend the on-off switches, and then again stop, wait, and loop back round. So that's what this code does. So I'm going to go ahead and I'm going to export that to the programming chip. And I'm going to grab that out of there, and you'll see that's got some code on it. And actually, before we go tearing off down there, we are going to need that second mixer, or third mixer I should say. So let's get that building. And let's just go and see, we've got 10 pipes in the backpack. Actually, I thought we had more in there. I think we're going to need a few more pipes, I'll be honest. I think we'll struggle to get those two lines between the CO2 and the nitrogen to connect without any more.
Filter low.
Although, you know, we might get lucky. Let's just create a few more just for a minute. While that's happening, let's just tidy up. We just had the filter low. That reminds me that we've got an empty filter, so we'll throw that in there. The other one, the next one down's at 86. We'll let that run and chew that up. 2.5 G of iron in there. Right, let's pipes have we got in here? 7. Well, I'm going to take a guess and say 18 pipes is probably going to get us nearly there at least. And then the other issue is cable. We've got quite a bit of cable, so all good. Let's go do some building. So first thing we can do is to let's put the chip in here. That leaves us a spare slot. I'm obviously not going to do anything more than just turn that on and off just so that it sets these, but I'm not going to even bother starting to wire those until I figured out where to put the other mixer. Yikes, this is actually quite difficult because we're going to need to feed the input in here, but we're going to need to combine the CO2 and the nitrogen, so this could get interesting. I'm pretty sure 18 pipes is not going to come close to doing it. Right, wow, this is really quite an interesting arrangement we're going to have to come up with here. So I actually think we're going to come in from above. I think that might be the only smart way to do this. Okay, well, first things first, let's get the CO2 line put together along here. Whoops. Going all over the place now. Again, nowhere near enough pipes. Look at this. We've barely reached the end here, and in fact I'm going to have to bring it from this side. Well, this is a real pain. Okay, so I think we're going to have to do never goes the way you want it to first time, does it? I think we're actually going to do something a bit like this. Oops, one small advantage I suppose, which is it's using slightly less to run the length along the back. Okay. I'm going to just pinch one off this end here. I realise I've still got to make just exactly the same number of pipes, but at least that way we know that this end is connected. Although I haven't connected up to the actual gas tank. So, this really is an interesting little problem actually. Let's go and make some more pipe. You'll see I'm being a bit slapdash with the jetpack now. Obviously we know that we can refuel it as and when we need to, which does help. Just let this build. The thing we will need, I'll go fetch that while it's building some more pipes, is the grey paint, if I didn't use it all up. But I think I did, if I remember. We've got plenty of orange. No, I think I did. And we'd better pick another colour to use for the CO2 and nitrogen mix. I think the choices we've got probably now are bright green or brown or purple. So I think we might go, I mean, bright green really is supposed to be nitrous oxide, but I do tend to use brown as a warning that it's pollutant, although that said we are throwing all the pollutant out, so I think we're going to go brown. Okay, I mean, whatever colour encoding you use, I guess the key message I would have for you is kind of pick one that's intuitive to you. Obviously it helps if it aligns in some way to the colour of the filters or other materials in the game, but pick one that works for you, that you will remember, and stick with it. You may not want to use this khaki colour as your waste gas colour. Speaking of which, I must finish with that. You might decide you don't want to use red for volatiles. That's all fine. Just pick one that you know you'll remember, because once you've done it, it's really important that you remember what it actually means, otherwise it's kind of all for nothing. Well, I suppose not quite all for nothing. It will at least help you to avoid mixing together two different gases by accident, but it's clearly better if you can use it to actually remind you what's going on. Now this really is fiddly. I'm trying to work out the best way to run a gas pipe through here. I think we can get one. Yes, we could get one through there. I might actually bring it through this side and put the mixer down here, except there's not enough width there. That would be the logical way to connect it. This is a real problem actually. I mean, otherwise I'll have to put it sort of above and here, but then that's kind of starting to interfere with other equipment. Okay, we might move this one. That might be the best solution. Let's just drop some stuff down for a minute because I really can't see what's going on. I think what we'll do is we'll take that out of there, and we will drop that. I say drop that, it was more like fling it into space. Right, I may regret doing this because I may find that there's just no way to line it up, but if we can I put that on there? Well, I can certainly put it there. The question is, can I wire it? And the answer is not a chance. So that's not going to work. So that means if we're going to do that, we'll have to put it there, but then that won't connect to the pipe. Okay, so this really is a bit of a problem. I think what we're going to have to do, I'll put that back down there for a minute, at least that way it was working. Let's not break something unnecessarily just yet. I mean, obviously I've broken the input ratios. Right, where are we going to put this other one? I've got to get the right mix coming in. Can we hover it up here? Maybe. Whoops. Maybe. Problem is we haven't got enough width there to get both the power and the gas. I think we're going to have to put it right back here. I think we have to put it about here, but I don't know whether we can then still get the cable to it. Don't even know how I'm going to get in to find out. I don't think it's going to work because no, it's going to hit that tank. This is actually a significant problem. You get these ridiculous things that happen sometimes where you just think this shouldn't be a problem, but it is a problem. And this is definitely one of those times. Okay, so let's think about some slightly different geometry. If we come down here, we've run out of, that's irritating, run out of power in there. Swap those batteries over. It's really not that helpful, is it, to have something like that happen when you're trying to figure out a different problem. Right, okay, so maybe we need to surface mount it onto here. Maybe if we do one of these, maybe that could work. Oh, if I can get the orientation right. Okay, that was what I was hoping for. That could work. I think the power connector's not too bad. It's a bit fiddly. I think we can do it. I'm not quite sure where we're going to run the pipes, but I think we can do this. Let's do the difficult one first. Or one of the difficult ones, I should say. Right, so that could come out of, it'll have to come out of this one though, because if we try and bring it out of there, I think that's going to interfere with, I don't know, maybe that will let us. That would be nice. Okay, good. Okay, that's a start. Okay, There we go. Right, we can win this. Okay. I think this is going to be all okay now. So, hopefully we can do this before we run out of power. Okay, it's not beautiful, but I think it will work. Let's very quickly connect that. And then we need to disconnect that and make that into a straight one. Disconnect that, and then that can go up here, and then that can go into there. Right, okay, this is some serious spaghetti, but it actually did work. Now what we're going to have to do is to get this lot painted so that we actually know what the hell is going on. So this is now going to be brown. Okay. Alright, we're going to need the black one. I forgot to do any grey ones as well. I need to do that. Spray paint grey. And actually we will need a spray paint khaki as well. Okay, let's let that print and get over here and try and sort this mess out. So that now is black, that is black, that is black. Okay, that's a little bit clearer, at least to me. Okay, and up and over. Let's get this done here. Whoops. Probably going to need another one. I'm not dismantling all this lot just for the sake of a bit of paint. It's much too much of a hassle. There we go. Right, we'll definitely need another one. However, at least at this end we can now see what's going on. Okay, so now let's actually set this up a little bit. So that's gas mixer, and we're going to call that CO2N. I know it probably should be CO2N2, but that's what we're going to call it. And we're going to call that one gas mixer air, and that one over there we're going to call gas mixer fuel. Okay, so this one, what we're actually going to do, we're going to want an atmosphere which is 70% roughly nitrogen. We just want to add a little bit, we really do want to only add a little bit of carbon dioxide. So I'm going to actually just add 5% of the carbon dioxide to the nitrogen. So this is now a 95% nitrogen, 5% CO2 mix. It's a lot of hassle for a few percent, isn't it? And that's coming in here through input 1 and then input 2 here. He said, just trying to check, yeah, input 2 is the oxygen. So the oxygen, we previously had 70-30. I'm actually going to go just down a little bit further to 2773. Okay. So what we should see here at the moment, obviously we've done none of the automation, is that we've got some nitrogen building up in that tank at a reasonable pressure, but we've got nothing in that pipe. We've got some stuff in that pipe, and the reason for there being nothing in this pipe is that at the moment there's nothing in here because it's not actually connected at the other end. So what we're going to do now is we're just going to zip down here and just pick up some stray pipes on the way, and we're going to connect it in here. Oops. There we go. And we're going to pull that into there. And now what we should see is that that pipe obviously should have quite a lot of CO2 in it, because we've got tons of CO2, which means this should now be starting to mix, but it's not. And it's not because this one's actually running too fast. Let me turn that off for a minute so we can see. So that's our 95.5 roughly. You'll see the percentages aren't exact. That's partly to do with the temperature differentials between the two and the way that the combined gas is cooling as it goes, but that's fine. But obviously what we don't want to do is leave this like this for a really long time, because you can see the pressure in this pipe is gradually creeping up. Now at the moment it's super low, but because this will eventually run out, that will obviously act as a brake on that, but left indefinitely, eventually this pipe here, the brown pipe, will blow up, which clearly we don't really want. Luckily though, we can turn that on and you'll see it's immediately sucked all of that out of there. So as long as the oxygen doesn't run out, which it shouldn't because we've got lots of it, then it should carry on making air mix here faster than this is making the CO2 nitrogen mix. So what remains now is to set this up to actually check the temperatures, which was obviously the point of this automation. So the good news is that now we have, I can't remember whether I actually ever, no, I never labelled the tanks. Now we have connected everything up, this becomes relatively easy. Why am I using that? That is not what I want to use. I want to use the labeler. We're going to call that small tank O2. We're going to call that small tank N2. We're going to call that small tank H2. We're going to call that nothing because I can't reach it. Come on. Thank you. Small tank, whoops, CO2. Okay, so what we're going to do is we are now going to map this through small tank O2 is the O2 tank, H2 tank is small tank H2, N2 tank is small tank, whoops, N2. Let's just check we've got that all right. Yep. Fuel mixer, air mixer, and CO2N mixer, and that's the reason we're not also monitoring the temperature of the CO2 in there, is that actually we just haven't got enough slots on here. So we're taking a little bit of a punt, but it's 5% of 70%, so really it's a tiny amount. And therefore I think we'll be fine. I mean, it's only going to be 3% or so of the total. Even if it's very hot or very cold, it shouldn't make a huge difference if the other two are in the right range. So right, fuel mixer is going to be the work out the quickest way to get to it. Gas mixer, fuel, gas mixer, air, gas mixer, CO2N. Okay, it should be as simple as turn that on. Oh, I thought we had an error then. No, we do have an error. Why do we have an error? I don't know. That was just odd. Okay, it's running beautifully now. So these mixers should continue to run as long as the temperature doesn't get out of range. And this mixer will stay off unless I turn it on. But if either that tank or that tank get too hot, which at the moment they're nowhere near, because if you have a look, we'll see they are both really, really cold. It's at 1 degree and that's at 2 degrees. So if either of these exceed 10 and that is turned on, it will turn itself off. So that is the first set of safety precautions in place that should stop us from causing quite so much destruction. I know that's sad, but you know, if you're going to build something, it's quite nice not to blow it up straight away. I have absolutely no idea what I did with the other spray can, or whether I took it back, or whether I dropped it. what a mess. There's a spray can, however, so let's grab that and tidy up what we can. Grab that and that, and also said we would actually, we'll need another grey one, won't we? We said we'd need another grey one, so let's just finish colouring up those pipes and then we are done. We've also improved the mix in our greenhouse. It'll take a bit of time obviously for that to filter through the system, but that will hopefully improve our plant growth. We're already effectively controlling the temperature in there with a better gas mix as well. I'm going to put that in there like that. With a better gas mix as well, we are nearly all the way there. The only other thing we just need to think about before we start putting in real industrial strength hydroponics is the water temperature, because we know that is an issue. Right, okay, there we go. So is that all done? That's all beautiful, look at that. Let's grab that. And see if we can sneak back here before dark. I don't want to paint the locker, I just want to open it. There we go. Right. Let's do this while we're here. Okay, so let's just check that this has all worked as intended. What we should be seeing is the gas in this pipe here. Yes, it's now got we've got the oxygen and the nitrogen backwards, I suspect. I think we've had this problem, well, I know we had this problem before. I'm slightly baffled because that says input and that's input 2. I know, I'm just an idiot. I've just done exactly the same thing twice. There's no reason to be baffled. It's just purely stupidity. So that should be like that. This is why we check these things rather than just walking away and leaving it. That's obviously going to take a little while to recycle through, not least because there's no nitrogen in there, because there's not much in here, although it is doing something, so we'll gradually start to move the ratios back in the right direction. Okay, right, let's think carefully then about how we are going to deal with the water, because we need to be able to get the water up to a nice 20-degree temperature and store it. Water has a very high specific heat capacity, so it will retain its temperature quite well, but we probably don't want to do that the way we've done it previously, where we've just used a liquid radiator in there and relied on the ambient air temperature. It's a good way of doing it with very small volumes, but if we were to melt large volumes, what's going to happen is going to be a bit of a mess. So I think what we'll do is, actually I think what we'll do while I'm here is we'll go in and harvest those potatoes. It's going to be a mess because what it's going to do is just bring the air temperature down faster than the heater can deal with it. So we're going to use a pipe heater, which means we're going to need to probably set up a proper tank arrangement. I think that the smart thing to do at this point, we've got the technology to do it, would probably be to build a insulated tank and place a pipe heater going into that and monitor it with some logic to make sure that we actually heat it when it's too cold. Right, we're going to need to do something with those potatoes quite soon. Actually need to do something a bit better with that fridge. It really isn't really fridging very well, is it? Perhaps we'll see if we can make it colder. I don't know whether that will help. Or we'll just need to cook the potatoes. We'll get to the point that we can just actually mass produce canned food, and that obviously is shelf stable, but we're some way away from that. So let's think about this water problem. if we're going to already use an insulated tank and a heater, that doesn't need to be inside. So I think we will construct something outside to support that. So with that in mind, let's move this way and pop back outside. Do I need a drink first? No, I'm okay for now. So okay. So we've actually taken 40 minutes putting some safety features in. I didn't know whether that was time well spent or not, but I suppose if it avoids us blowing the whole place up, it probably was. Right, let's have a look at insulated liquid tank. Kit tank liquid insulated, there we go, that's the one. So we're going to need silicon. Okay, well we should have some silicon. Let's grab some. I'm wondering whether the first button press after a reload actually is not functioning, because all of these, the first time I've used them, nothing has happened. Although this is now spoiling that theory by not working on the second or the third, although I have a new theory, which is that we may just have run out of silicon, which we have, so that's the problem there. Really difficult to vent something that doesn't exist, I guess, so I'll give that a pass. Right, okay, have we got lots of silicon anywhere else? No. Really no as well, so I guess that's the next thing we better do then, is go and mine some. It's funny the things you run out of. Right, okay, actually before we do that, let's see if I can just any space left in there? Really not, is there? No. Right, okay, fine. Right, let's go. I think we'll turn the jetpack off, otherwise I'll fall down a hole, needed to get out and find I've used it all. If we can sort out the water problem, then we can start to do some mass mining of water ice, which is also a great source, obviously, as we know, of nitrogen, which would be great. But for now I'm looking for the other white thing. No. 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 There is some. Okay, we don't actually use huge amounts of silicon, so if I do a reasonable stock up now, we probably won't need any for a little while. And I will top up the rest of the capacity with probably some iron, because you never have enough iron. Although, to be fair, whoops, I think some of that fell through the landscape then, unless well, again I'll have to watch it on the playback, but definitely looked like it. Okay, well that's it, that's all we can carry. It's a shame, I was hoping for a bit of copper, but that's what I get for going out. Wait, hang on a minute, we can do this. Right, we just need to do this, except that we need to just get one stack and leave the rest, because literally there's nowhere else to put it, but at least that's a little bit. So you can see, obviously, as we've built the base out now, and we added that light in the ingot store, it actually makes it quite a lot easier to see the base from a distance, because that lights things up, but also just because there are so many more structures to catch the reflected light from that, so that does help. Probably just as well, because it's only just occurred to me that putting that wall there screens off all of the machine lights here, but anyway, there we go. Right, okay, let's throw in the thing we're actually waiting for first, and then we'll throw in that one, and then silicon actually outgasses quite a lot of nitrogen while it's smelting as well. And one other thing we could think about doing later on is enclosing these two arc furnaces and capture, you can see some of it coming off here, capture some of that gas, but it's probably not worth it, to be honest. But you can see there is a bit coming off there. Not a huge amount in the scheme of things. If you think about the nitrogen content, 2.9%, it's enough to bring up to 3.9% at spikes, but it's not massive, but over time it would build up. So we could think about that. But to be honest with you, it's probably not worth the amount of hassle, because we probably have to move these in order to make space for an enclosure, and then we'd have to well, it's probably not even worth thinking about. Actually, I'm traumatized just considering it, so let's not do that. That's a stupid idea. Shut up. You suggested that. Right, have we got any silicon? Come on, silicon. I didn't need any more copper. I thought I did. Okay, actually we've got a couple of blocks of gold. We do need more iron. We always need more iron. We've got some, so that's cool. Okay, right. Copper in that one, so the silicon must be in this side, which is the one that's harder to see because you can't hover over the button because it's inside there. Oh well, I guess we'll just have to wait. That's fine. Okay, so let's think about a bit of planning in the meantime in terms of where we're going to put this water. We're going to need to be able to deliver water at the right temperature into the main hab, or at least into this section where we're going to have the greenhouse, although I do think we might bring this out a bit further. I think we could do that. We could actually probably need to disconnect all of that ice crusher, come up with a different arrangement, but we could actually bring the greenhouse out further, which would give us a lot more space. So I think we'll lay down some frames to do that actually, whilst we're waiting for that silicon, because what we don't want to do is just be standing around waiting really. Where is the silicon button? There it is. I have pressed the silicon button. I have not received the silicon. I think that means there is no silicon still. Okay, well never mind, probably come out when it's ready. I think that's enough there. Okay, we're going to need a reasonable number here because these will need to be double welded so they're airtight, because we're actually going to extend what we've got there. Okay, that's probably enough for now. I guess the other decision to make is whether we go with continuing to use iron frames here, or whether we go to steel, which obviously, if we do, will not match what's already here, but we could make that change over. I think for now let's just get this welded up and come on. At this stage I'm not suggesting bringing the wall any wider, but I would like to bring it out one more block. So we're going to need 1, 2, 3, 4, 5, and then across the top 6, 7, 8 walls. So let's, we're going to need 8 iron sheets as well, so we'll know we've got 6 here. We're going to need 2 more. Okay, let's we've got plenty of glass. Okay, there we go. So this is going to go on there, and oops, on there, on there, on there, on there. Okay, now let's build these and add the glass, and we'll be inside. Nearly. Whoops. And I think once we've done this, we'll probably call it a day for this video. Right, that's all sealed up. And we'll start work on the water system next time, because actually we're coming up to another hour. Amazing how time flies. Right, okay, are you ready for some explosive decompression? Good, I sure am. Let's take this one. Now obviously what we've done is effectively increase the volume in here by 50%, so that's going to reduce the pressure, but not to 0. Look at that, it's down to 70. And obviously that's caused things to get sucked through, but that's okay. We'll take those off there, and then we'll very carefully remove the, oops, I needed the crowbar for one more go, didn't I? Be very careful not to look anywhere near the actual outer walls where I could accidentally slip and remove the wrong piece of stuff with the crowbar, because obviously if I slip and remove a pane of glass from the outside, we've got a real problem. I forgot that this had run out of power, or that we nicked the power out of it, I should say. So it must recharge that battery. Anyway, in the meantime, okay, so one downside of this is we've now ended up with 3 extra walls there that we didn't need, but I'm sure we'll use them later. Another downside is that we've just still got just as much mess in here as we had before, but the upside is we've now got a bigger space to work in, which is great news. Oh, where on earth did that end up? Whoops, sorry potatoes. That was not what I expected. Let's try that one again. That was more what I expected. I was just going to move them over there. Right, we can create potato seeds as well while we're here. That's always a bonus. So there we go. And that one. And get around here. There we go, 8 potato seeds. Okay, we shall add them to our pedestal of... no, we shall not add them to our pedestal of potato seeds. Okay, now we just need to recycle that airlock to actually be able to get out, because obviously we came in a slightly unconventional route. Now longer term, obviously we'll strip out that pipe. We'll probably move all of this. We'll run that waste pipe around the outside. But let's worry about that on another video. Now while we're in here, actually I'm going to have a drink of water and an eat of food. So let's unlock, open the helmet, let's eat some soup, let's drink some drink. I feel like you should get some hydration from soup. Let's put that in there, put that in there, close the helmet, lock the helmet, and then actually I think I'm going to call that a day for this video, because we're just about coming up to the 1 hour mark. Some of the other videos really are quite long, so it feels like maybe stopping this one at 1 hour is sensible. And we can then start work on our water tank project next time, but this time we've added some safety features to our gas mixing, and we've extended the greenhouse, so that feels like definite progress. We didn't even kill any plants at all in this video. So I hope you've enjoyed that, and I hope to see you on the next video.